All right, everyone, it is now 2:30, so we can get started. Thank you all for being here today. And welcome back to another lecture for Comp 290, Essential Tools for Computer Science. This is lecture 12. We are nearing the end of the semester, and so there'll be a slide on this, but this is the third to last lecture that we're going to have this semester. So let's try and end it strong. We're hopefully going to be talking about some extra things and extra tools, which will be very useful and hopefully is of interest to you. So before we get started with the material, I want to go over some announcements. So first off, amazing job on the final project proposals that you all worked on and submitted on Friday. I had the chance to go through all of them and release the grades by Sunday, so they should be in Canvas and on Gradescope. It's great to see that, you know, the proposals that you all worked on were really well thought out. There were some great ideas, and you all found amazing documentation. The designs that you all made were really, really nice. Some people chose to do it and draw it by hand. Some people chose to do the optional Figma extension. So amazing work there. And so the grades for this particular assignment should be posted on Canvas. So if there's any mistake there, let me know and we can get that fixed. Now, another thing that I do want to mention is that out of around the 56 students or so that are in this class, we only got around 46 to 48 submissions for this. And I want to stress that, you know, the final project grade, remember, is a pretty large portion of the overall class grade. I think it's around 40%. And the proposal is 30% of that, right? So that, if you do the math, is kind of equivalent to an entire letter grade worth. So please try and get this in. We extended the late due date until today. So please submit if you haven't already. Now, I think there are some of you who, for various different reasons, had to delay it because either didn't have a computer or didn't have access to the Getting Started tutorial on time. So those extensions, you all are fine, so you can continue working at your own pace. But please try and get this in. We're not trying to grade this very harshly. So as long as you include the material that is in there, you will do more than fine. Okay. So does anyone have any questions about the project proposal or the way the grading worked or anything like that? All right, good. So again, another thing here, yes, we are nearing the end of the semester. We have only 3 more lectures, including this one. So we are kind of wrapping up here. And one thing that I want to mention, and one thing which will be on the next 2 lecture slides as well, if you are new to UNC, you might not, like if you're a freshman, you may have not seen this already, but if you're a sophomore, you've had 2 experiences with this. Near the end of the semester, the college opens course evaluations for all of the courses. So students can fill out an evaluation about how they thought the course went, how the instruction was, and for pilot classes like this one, and any 290, 590 classes as well, whether or not this course should be offered again. And this particular tool is the most concrete and the best way to be able to share your opinions about the class. So if you see an email coming out about course evaluation soon, please fill this out. It'd be really helpful for us. If you want to see Comp 290 offered again, let's say next semester or in the future, this evaluation will be the way that we can make that happen. And it also helps us as well if we are to be teaching the class again. So really appreciate if you all fill that out whenever it comes out. Okay. So just again, to remind you about the final project timeline, the progress check will be due on Friday, so this Friday, for the Getting Started tutorial. Now, I want to stress that this particular progress check is not, it doesn't count toward the final project grade. It's basically a check mark that says I have completed 50% or more of the project. Okay? It's kind of a way to help you to, I guess, remind yourself that we're nearing the end of the semester, so it's a good idea by this point to have finished at least half of the Getting Started tutorial. That way you're not scrambling and have too much work coming on the other side during Thanksgiving break, etc. Okay, so that's open now. You can fill it out now if you want, and that will not count toward any grade. What will count will be these next 2 things. So the Getting Started tutorial and the project plan submission, both are now open on Canvas, on Gradescope, including the project plan, right, the action plan. So highly recommend checking it out. It's again going to be inside of that GitHub repository The template for the action plan is there, so you can modify it, and this will be open all the way until the last day of class. And you can submit early too. I think already 2 people have submitted it, and out of those 2 submissions, they looked great. So amazing work there. And then, of course, we will have presentations. So in lieu of final exam for this class, unfortunately, sorry, Friday, 8 a.m., that's what the college gave us as our final exam time. But we will have presentations there. Now, I want to stress, so by the end of the week, like Friday, we'll have a much more concrete details about this. But I will say, going into this, that it's not going to be like you have to come in front of the class and you need to present to everybody staring at you. It's going to be more in groups and slightly in a less formal. So it's not something to be stressed about. It's just showcasing what you have all learned throughout the semester, working on the Getting Started tutorial and working on your project plans. Okay, so does anyone have any questions about this? Also, I realize the recording is now on. So any questions? Great. And of course, as always, we're always available at the end of class or by email if you have any questions about this. All right, so I'm going to now hand it over to Noah to talk about some exciting opportunities that are coming up in our CS program.
Yeah, so some fun things happening. This first one here is a study abroad program that's coming up here for this coming summer. So that'd be after next spring semester. And this is specifically going to be taught by CC McMahon, who's an instructor here in the department. I've personally TA'd for her and taken a class with her before, and she is really, really good. Yeah. She even I think her master's was in computer science education specifically. So
yep, she won her undergrad teaching award as well in her first semester, first year here.
Yeah, so she's the real deal. And I have some friends who have gone on this Copenhagen study abroad with her before, which is going to be for Comp 311. And that was this past summer. They all loved it. It was a great experience. And it's not pictured here in the slide either, but she will also be hosting Comp 380, which I believe that satisfies like a philosophy credit or something. And that will be in Stockholm this coming summer too. So it's not on the slides, but if you are looking to take either of those classes and can make a study abroad work, would highly recommend. 311 here is going to be in Copenhagen in Denmark, and 380 in Stockholm, Sweden.
Yep, thank you. And also another thing I want to add here is many of you are currently students in Comp 210. Next semester, you'll likely be taking Comp 211 with CC, and 311 will be the extension of 211. It kind of goes into the computer engineering, more hardware level topics. So we highly recommend it. And also Comp 380, if you're doing the data science minor, it is one of the requirements for that. So it's a great chance to just have study abroad with a great teacher. So another thing here is on the study abroad website, I will very briefly show this. You will see, sorry, let me go all the way back to the homepage. So UNC study abroad. Okay, so if you're trying to look for more information about this, this is what our website looks like. And specifically, because this is taught by Professor McMahon, this is a faculty-led program. So you can find more details by going under programs. Yes, choosing a program, I think. No, sorry. Program types. And then under faculty-led, there's a button for faculty-led program. You can click on this, and then you can search. So like Comp 380, 380. There's some info about that right somewhere. Wait, what is it? Well, you can see the 311 one. I forget, the philosophy one took a minute to find, so I have to, it's like computing. Well, I don't see it here, but there will be a link. I'll post it out in the announcement in Canvas at some point. This was here yesterday, but she is definitely offering it. It's just this website is not that great, so it's sometimes hard to find things. Also, in addition, you can always email her as well, and she will have. Let me see if I search Stockholm. Yeah, there's nothing showing. There it is. All right, there it is. Stockholm. So UNC Technology, Ethics, and Culture in Stockholm. That's what it's called, Comp 380. Yes, so you can see here when you click on it, there'll be information. If you've never kind of looked at study abroad before, it'll tell you about the dates, the location. It'll talk about, a priority, if there's, and how to actually apply and all of that. And you can see that there is a date as well somewhere about, I think maybe under apply now. Yeah, there'll be information about how to apply. So I think applications are rolling, so the earlier that you ask about this, the easier it'll be. So recommend it. And I'll hand it off to Noah to talk about one more thing.
Oh yeah, so final announcement here is coming up here, February 15th to 16th is another hackathon hosted here at UNC called Pearl Hacks. And this one is specifically for women and gender non-conforming students at the school. And it's a great opportunity. It's very beginner friendly. So if you attended Hack and See, you liked it, or you didn't have the chance to, or you're just interested, they're really great. They're run by a great team. I know a few of the people there. They have mentors there too to help you out if this is like your first experience in a hackathon, and they have fantastic prizes as well. So yeah, highly recommend. Check it out. Pearlhacks.com, I believe, is their website.
And it's also a great, even sometimes a lot of these like Hack and See as well, there are people, and Pearl Hacks as well, people from other universities might be there, so it's a good way to meet more people and to network as well. Any questions about study abroad or Pearl Hacks or anything like that? Great. It looks like we're ready then to talk about today's topic. So I will first get started here by kind of reminding everybody where we have gone so far. You can see that at first we have talked about Vim. This was last lecture. Chris did a guest lecture on Vim. Noah talked about IDEs and developer tools, and all of this is really part of this last module of the course, which is going to be talking about different tools, miscellaneous tools, that help to improve what we call the developer experience. Okay, so this is often sometimes in short form called DevX. Yep. And the entire point of this is, we want, as software developers, we want to make our life easier, right? And so we are looking at all these different tools. We try out tools like Vim and these different IDEs and other things so that our day-to-day coding and working on these different projects of ours becomes easier. Now, in the last few years, there has been a new tool that has come about, which has perhaps changed everything, not only in the computer science context, but also elsewhere. And that is, of course, generative AI. So I want to preface here, and there's a lot of emojis because this is the most requested topic that we have had so far about things that, when we ask you what would you like for us to talk about, this has come up a lot in all of the forums. So the September survey, the beginning of class survey. And so we wanted to kind of introduce this holistically and talk a little bit about how generative AI works and also how we can use it to improve our developer experience, our day-to-day software development tasks. So to start off, I want to talk a little bit about what generative AI even is, right? And we can kind of, I have this diagram which might help to describe how interacting with a generative AI tool works, right? So first off, generative AI, it is just a system, right, that generates new content. It's kind of in the name of generative, right? We're creating something new, whether that be text, whether that be images, whether that even be something like video or audio. And we do this based off of a prompt that the user inputs in, right, to the generative AI tool. So for example, with ChatGPT, you may supply a question, that's kind of a prompt, you ask about something, and then ChatGPT will do something behind the scenes, right, magic, and then you get some content coming out the other side. Now, I want to talk a little bit about here, we have this box, which we call a generative AI model. So a lot of people have probably heard this term be used around, this model, and we'll be talking about that today. Model is unfortunately a word that's pretty overloaded in the computer science world. We use model to describe a lot of things. But in the context of generative AI, as we'll talk about, models are basically just an algorithm. It's a system, it's an algorithm that, just like any other computer program, you give an input in and you get some sort of output right out on the other side. And that's why I want to emphasize here, it's just like everything else that you've used, even in Comp 110 or 210, where you run a program, you supply something in, you get something out. That is how a generative AI model is ultimately working. Now, you'll notice that most of the time, when we use these AI tools like ChatGPT or some other favorite tool, it's often treated kind of like this magical thing. It's this omnipotent being that you just ask a question and it just spits out some sort of answer, and it's kind of just correct and very, very smart, and so you trust exactly what it says. And this is a problem when we kind of start to treat generative AI as some sort of magic, and we kind of just trust it on its word without really understanding what is happening behind the scenes. Right? There are some problems that can arise, like reinforcing misconceptions about how these type of models work and how something like ChatGPT actually comes up with a response. And it can also lead us to maybe incorrectly expect these generative AI models to always give the correct answer, or to always say something that should make sense or be correct. And so by kind of abstracting this out and just kind of using this AI tools without really understanding how they work, it can lead to different problems. Now, the key thing here is yes, right? Generative AI is not magic. There is actually something happening behind the scenes, and it's actually something that, even though there's a lot of high-level mathematics and maybe linear algebra, machine learning and stuff going on behind the scenes, we can still, even in a class like this, be able to introduce it and to explain it in a way that actually helps to demystify how this thing works behind the scenes, right? And so first off, most modern Gen AI tools, Gen AI is kind of a short, sometimes people use a shorthand for generative AI, like ChatGPT, they use something called a large language model, abbreviated to LLM, right? LLMs. And this model, again, model's coming up again, so you can see why this term is used a lot, and it helps to generate responses, right, and create new content. Specifically, this is for text-based generative AI, so like ChatGPT or Llama or whatever, where you ask it a question and it writes out a response for you, right? That's what a large language model is based on. There's also other things, like I think there's like a vision models, right? So if you're trying to create images or create videos, you may use a different system under the hood. But today, because this is the most simplest and also the most commonly used tool, we will be talking about text-based generative AI. So an LLM is just an algorithm, right? This is something that we want to stress here. It's just an algorithm. It isn't this crazy thing. It's an algorithm that performs a large variety of different language processing tasks, right? So NLP, some of you may have heard of that. We offer some classes on it. And basically all that allows this program to do is it enables it to be able to recognize text, predict things, which we'll talk about, and generate text in context. So context being, for example, a question that you ask the AI bot, or if you had a chat history with it and you've been talking about something above, that's all part of the context that the model looks at. Now we call this a large language model, large because it is trained on a very, very large amount of data. In fact, something like ChatGPT has read nearly everything on the internet, and it's using all of that text, right, petabytes of data, to be able to tune this algorithm to work correctly. Okay? And all this algorithm does is, based off of all of the text that it's seen in the world, on the internet, etc., it's able to be able to find relationships between different patterns of text and sequences of text. And ultimately, that is how the algorithm can infer meaning in a sentence, right? So by just taking all of the data out there, finding trends amongst how words are kind of laid out, it's able to compile information about the text.
Yeah, and one quick thing I think is good to add on here is to accommodate this extraordinarily large amount of data and actually capture all the intricacies of the data, the models themselves have to be extraordinarily large as well. And if you actually look at like something like ChatGPT, right, that one's actually not as public, but if you look at some of these like top tier open source models like Llama and sort of these cutting edge ones, you see they actually end up requiring like machines with on the orders of like hundreds of gigabytes of like specialized VRAM for processing or just running the models. So they're extraordinarily large, and they actually are starting to have an environmental impact in some regards because they require so many resources to run. That's just a little aside. They're just huge. Keep that in mind.
Yeah, no, that's a really important point. And also, that's also why, if you've heard in the news, companies like NVIDIA becoming extremely, popular and valuable in general. That's because they're the ones making these different units for processing. Yeah?
Aren't these companies starting to invest in like nuclear power plants to like get their own things running?
There's definitely some, I don't know about nuclear specifically, but I wouldn't be surprised. But
Yeah.
there's definitely like pushes. I think Google is trying to, like, there's this trend towards trying to be carbon neutral as well. But then even beyond that, you're right, like they're so power hungry that they are trying to like offset as much of that as possible. But yeah, still it's a problem.
Yep. So, this and large doesn't really, I guess, fully represent or encompass, like, it is astronomical amount of data, which is why it took until until computing even and computers got to a point to be able to process this amount of data that we even have something like ChatGPT, right? Not only is it a software innovation, but also the hardware underneath is a very important thing to make all of this work.
Sorry, I thought, do we?
Yeah, I even saw not even carbon, but like water. Like they consume so much water from the heat that they want to like set a goal to be like water neutral eventually, which is
Yeah, a great point too. Like if you think of these massive data centers that are like many football stadiums long, and you have to actively cool all of those too, water ends up being, liquid cooling ends up being one of the best solutions. But as a result, like you said, you end up having a ton of it evaporating, and you're just using a lot of fresh water supply for just cooling computers, which otherwise would be drinking probably. So, yeah.
Any other questions about any of this information here? All right, so we've kind of introduced this idea that generative AI, especially modern text-based AI tools like ChatGPT, use these things called large language models. So now we're going to talk a little bit about how this language model actually generates the text that you see, for example, as an output of ChatGPT. And I'm going to start with this kind of very base notion here, where we take a sequence of what we call tokens. And we're going to get into what a token is, but I want to introduce this first. We take a sequence of these tokens, we input them into our language model, and then it generates one single token based off of what was previously passed in. Of course, you're wondering, looking at this, what is a token, right? So a token is actually just a unit or like a small chunk of text that is used by a large language model. So when you have, let's say, a sentence, and you input a sentence or you ask a question into GPT, it takes what you write and it kind of chunks it up into these different units. And these tokens are then used by the machine, and there's a set, right, of a large amount of all the different possible tokens. And each token represents kind of a unit of meaning or a unit of, in some cases, punctuation, as you can see here. So typically short words, often they're their own token. Longer words, though, like for example, generative in this sentence, wow, generative AI is so cool, right? Generative might be actually split into two different tokens. And they actually, you can kind of tell by looking at it, like majority of the meaning of the word comes from the first token, right? This gener, and then ative is kind of a modifier onto it. And there's also some interesting parallels with different concepts and, for example, other majors and minors like linguistics and information science here as to how these things are actually split up into different tokens. But the key thing I want to show, there's a link here that's this tokenvisualizer.netlify.app. And I want to open this up. So, all right. So this right here is a very, very nice tool that I found while researching this. It basically allows you to put in text and actually see how different large language models actually tokenize the text, right? So GPT 3.5, GPT-4, this powers ChatGPT right now in its current iteration. And so, like, for example, if I were to put the text that I had on the slide, which was, wow, right, generative AI is so cool, you can see that it takes this text and it generates 9 tokens out of it, right? So it generates, most of these are words, 2 of them are punctuation, and 1 word is split into multiple pieces. Now, I can show another example here, and there's this nice show example button. And you can see that a large amount of text, let's say a paragraph, would turn into all of these different tokens, right? So, tokens are a piece of text. You can see here, this is all split up. There might be one word. I'm trying to see, there might be one word split up, but you can see that there's like, punctuation, something like, this EG here, right? Example is split up into multiple different tokens. So it's pretty cool to take a look at this. But another key thing is that if I switch my tab from using this GPT-4 LLM to say this llama, which is what Noah was talking about easier, watch the token count, right? So you'll see that the token count actually increased when I switched the model, right? And then you can see there's some different things, like tokens, for example, is now split into two, right? That word is split into two tokens, but over here it was just one token. And so the intricacies here are, depending on the language model that you're actually using. So the different language models will chunk up text or tokenize text differently. And this is why, when you ask, for example, you ask ChatGPT or you ask Llama, these are completely different models. The way that they're trained is different, the way they're set up is different. And so they will have different results, and they'll interpret your text differently because, they're looking at text through a different lens with different ways of tokenizing. Okay. Tokenizing is kind of that term used. If you ever see that around, it's just the process of taking like a paragraph and turning it into like a list of tokens. And then GPT-2, you can see GPT-2 is another one. This one has 99 tokens. Like the word punctuation is split into two tokens here. So that's kind of an interesting, it's interesting to take a look at this. You won't really gather much, especially if you're just trying to use generative AI tools. How it actually tokens up things, the specifics are not too important, but the idea as to how it reads text is. Are there any questions about the process, or well, maybe not the process, but just what a token is and how text is converted to tokens? All right. So now taking a look at this, and we now see that we have text. So tokens are just units of text. We go back to this example where we have n tokens, so any set or a sequence of tokens. We put it into this language model, and then the language model will generate one single token back. So how does this actually work in terms of generating text? Right? So this is an example where, let's say we take 4 tokens, right? Keep, calm, and carry, right? These are 4 tokens. We pass it into the large language model. And what the language model does is it's going to predict what the next token should be based on what you have already passed into it. So we have, for example, keep, calm, and carry, and it's going to look through all of the different possible tokens that are available, and it's going to find which one is the most likely to show up next. And then it's going to generate one new token back. More specifically, you can see something like this, where the language model is going to, let's say these are the most common. Like, you could say keep, calm, and carry on. That is the common expression. But you might say something else, right, in natural language, like keep calm and carry the apple, right? So maybe apple, or like the apple, could be another continuation of the sentence. Or keep calm and carry it. Or keep calm and carry an apple, right? Something like that. Those are all different ways of completing the sentence. But based off of that large amount of data that it read at the beginning in that training step, right? All the internet's data, it thinks that the most probable next token is going to be this one. So this is the highest probability, and so it generates that token back.
Question?
And if
Yeah.
this is based off the probabilities, if 2 people write the same prompt, why would it give them 2 different answers?
Yes, so I think there's a few different things. I would say, this model is run every time somebody asks a new question. It runs it at that time, and the process of coming up with these probabilities is kind of it's doing a bunch of math and a bunch of stuff behind the scenes, and it's not always going to be a one-to-one. It's not always going to be a one-to-one thing. So there's different tweaks that could happen. One being if somebody very slightly tweak the problem, or let's say the model was trained on new data, or just the fact that there are multiple tokens that are very, very close in probability, and so it just chooses one. The actual choosing step, this is a more simplified, this version of kind of just choosing the most probability is a little bit more simplified. Models these days are sometimes more sophisticated, and so they might, instead of choosing like the first one, it might try and do a little bit more thinking, and more calculations to find which one it should show.
Yeah, specifically for that question, like if you give the exact same prompt twice, there's this, you'll see there's, in a lot of large language models now, there's this special parameter called temperature, which is actually like this number that you can sort of tweak between, I think it's 0 and 1, but that is like what you change. If you want more randomness, you actually increase the temperature, meaning it's gonna slightly, like Ajay said, might choose something else that's a little more, it's not the top result, but it'll introduce a little bit of randomness. If you want to take that out, you can actually experiment with some models. Turn the temperature, there's a lot of parameters. I think temperature is the one that controls this. If you crank it all the way to 0, you'll get the exact same output every time. Unless, like Ajay said, the model is like training itself and it's updated something. But assuming the model stays constant, you can actually try that out yourself and see you'll get the exact same thing back.
Yeah, great question as well. It's there's so many, as know, like with temperature, there's all these little things which are really, really cool, and they're adding to models, as they develop. And in a higher level class, they go more into like the specific parameters and fine tuning things. But that's a good question to think about. Also, you're looking at this probably, and you're wondering, well, we have a sequence of tokens. It's generating one back. But when I ask ChatGPT a question, it doesn't just give me one single token, right? It writes a large response. So the question is, well, aren't the responses much longer? Yes. And actually, the process of generating a token every time, that's going to repeat itself all the way through writing a very large response. So for example, you could imagine something like this. Now the probabilities and how everything works here, you could just assume that these are the tokens that it chooses. But how it works is the model might select the first token. Do I have my tool? Let's see, does this work still? No, it doesn't work. Very sad. Okay, that's fine. I'll just point to it. So at the top might be the first token that you pass into the model, along with maybe some sort of, you pass in some sort of question and say that it generates the. And then it will take that token, it'll again pass it through the model, and it will generate the next token, right? Quick. This is the token that's the most likely to follow this token based off of the prompt or the input that the user passed into the model. And then these two, so the original sequence plus the new token, is then passed in again. So this is combined and now used as the input in the next row. So the quick is now the input, and it's going to generate, based off of this, the next token to be brown. And this can continue on. So you can see that these three then are used as the input. This generates a fourth token, then these 4 tokens are used as input, and it generates a 5th token, and so on, all the way until we reach a point, and there's no, you'll see here at the end, I didn't include, because I ran out of space, I didn't include a period as a token. It probably would lead to that token, and then it would say that we are done responding. It's more likely to respond with nothing than to continue on. So the idea here is basically that a language model, especially the ones like GPT-3 and GPT-4, they generate tokens one at a time, right? So you start off and you're generating all the way down. And that's why you'll see in like ChatGPT-3 or ChatGPT-4, when you talk to it, it's writing, it doesn't just like dump a bunch of text. It's not just an animation. In effect, it is generating tokens as you continue going around. Yeah?
How does the model know when it should be done?
That is something that I am not entirely, I don't know.
What was the question?
Yeah.
How does the model know when it should be done?
Oh, when to stop?
Yeah.
That's a great question. So like Ajay said, so there's a point where when you reach sort of the end of the sentence, you're probably going to stop, right? So if we see the quick brown fox jumps over the lazy dog, period, like Ajay said, after that, like predictably, there's a chance that we'll stop. And the way that actually works in practice, so You saw how there are tokens that correspond to each word or parts of words. There's actually unique tokens, I don't know if they were shown in the tokenizer, but that are specifically called start and stop tokens. And these are tokens where their sole purpose isn't actual text, it is to control the, like, if you're gonna start generation or stop generation. So if we actually, sorry, Ajay, would you mind going
Yeah,
back 2
so-
slides?
Yes, oh yeah, the 2 slides. I will show that this might be the start token. So this
Yes,
is in
so,
Llama.
yeah.
The Llama visualization does show this S, right, which is not in the original
And can we
text.
scroll to the end? I think there should be.
I did not see anything at the end.
Okay,
Yeah,
no,
but-
it's not visualized, but if
Yeah.
you go back 2 slides actually.
Mhm.
Yeah, so here, just as it's projected, or in this case, predicting like on the, it, and, there's a special stop token that could also be predicted, and it will be predicted probably at some point, and then if that's like the top priority, it'll just take that and choose to stop there.
Yeah, so might imagine I can even, I'll add it just for the, I can add like stop.
Yeah.
Or like something like that, stop. Just so that it's in the slides, so it's represented there. Okay, perfect.
Great question.
All right, so what this means ultimately, right, is that as you continue generating, you're taking your result and you're passing it in, and this process continues until you reach the stopping point. Any questions about this process? All right, now this is going to be a well, actually, before I get to the discussion question, I do want to mention one thing. So, because you noticed, right, that our model is generating, token by token, and we're generating a new token along every step. We're repeating this process every time, right? So this process where we calculate a probability and then we choose, there's maybe the temperature, that randomness attached to it, and based on the context, it then chooses the next token and it moves on. But you might be wondering, well, there's all these different types of models that we have, and sometimes, there's some apps, like for example, I think there's like some realtor app where there's a chatbot and you can talk to it and it tells you a lot about like about real estate. There might be some other business chatbot. So what actually happens then with these probabilities? And so these probabilities that you see here are influenced by the data, right, that the model was trained on. So for example, if ChatGPT, for example, they trained the GPT model on everything, like everything on the internet. However, if you were trying to make your own large language model, or a company is trying to make their own language model on something, they might not use everything. They might narrow down the data that this trained on, or it might give certain weights, right? Weighting meaning that we find this particular data that we're passing in more important than others to kind of reason with and make predictions. This will skew the probabilities from kind of the base model, so that it's more likely to answer questions correctly on specific topics or specific domains, right? So this is how, when you see, for example, if Duolingo, I think they did come out with like some language learning, LLM, something like that. That's because they trained that model on different data than, for example, a realtor website would.
And
Yep.
so, let's see, what problem? Okay, I just want to make sure I wasn't answering the question
Oh,
on
yeah.
the slide. Some other really interesting use cases beyond just, I think a lot of the times with LLMs, it's easy to get bogged down in just the pure text generation aspect. So you think, a lot of people only think to apply it to chat situations where you're chatting with a realtor, or pushing the limit is like, language learning, like with Duolingo. But there's actually a lot of scenarios where this applies. You'll actually see there's a lot of research right now going on in like the material science field, where material science is, I don't have a super solid understanding of it, but at a high level, it's just like studying sort of mixtures of other materials to, get some property that you want. And there's so many different combinations, it's hard to just know off the top of your head, oh, which ones are promising, like which ones should I explore? So people are taking these massive material data sets, training models like these on them, like massive models, in hopes that these models will be able to sort of extrapolate some sort of underlying meaning from this data. And then when they ask it, hey, what are some potential sort of combinations of materials for these properties, it returns a list, and then that sort of combined with their knowledge that, okay, these might be some promising candidates to explore that they weren't able to think of beforehand. So there's a lot of uses beyond pure just chat that are being explored right now and played with.
Definitely. Even healthcare comes to mind. That's
Yeah.
one that's probably actually for everybody in terms of your day-to-day life. the healthcare, the intersection between AI and healthcare would probably be one of the most transformative transformative tools for healthcare professionals. Also, another thing is like, we were talking about this with Chris Jordan is to like, maybe for advising, like UNC computer science advising, we could use all of the resources on the CS department's website and from professors and whatnot and put it into this type of model and train it so that you can have like your own CS advisor based off of that data. And that's actually something that we might be looking to do next semester. So that's an example to show how, how this can really be applied in the real world. Now, one thing I wanted to discuss real quick is, and we'll take maybe 1 to 2 minutes on this, is what problems might happen or might arise if tokens are generated one by one, right? What could this potentially lead to if you're trying to ask a question and it gives an answer? What might happen to that? So we'll have everybody in their row, again, talking with each other about this. We'll give 1 to 2 minutes and then we'll come together and discuss.
There we go. Okay, and we had a brief question here, which I hope we can shed some light on, but specifically what it means for a model to be trained. So I realize it's sort of it's a very high level concept. The idea comes from the whole like world of machine learning, which is a area of computer science right now, which is very closely tied to AI, but not exactly AI. But the idea is that up until this point, when any programs that you've written for classes, you've probably had the notion of you have like these exact inputs and these exact outputs that you want. And so you write the algorithm, you tell the computer exactly how to transform those inputs into outputs, and there's nothing really like nebulous about it. You're sort of giving exact instructions to the computer. On the opposite side, the idea is that this is a really reductive example, probably missing some nuance, but like if you just put a person in a room with like thousands of books and then just gave them like enough time, the idea is that they'd learn how to read. Like that probably wouldn't work in practice, but like the idea is there. Whereas like instead of teaching a kid explicitly how to read, you just put them in there with a whole bunch of data and you say, okay, learn from this data, sort of figure it out yourself. And the idea is with enough of that data, hopefully that person, or in this case, some algorithm can sort of find meaning in like these repeated uses of characters in this case, or tokens, and sort of extrapolate some meaning there. So that's what training means. It's just this process of taking a whole bunch of data, giving it to this algorithm, saying sort of like, okay, try and learn what you can from this. And this is actually a tool, which then includes its training. And then what you're using it for right now is actually the opposite step. You're not training it anymore. Once it's trained, it knows, and then you can just sort of give it input and expect output. It's not doing training when you use ChatGPT. If that makes sense. Are there any questions from that? Is that clear? Yeah.
Does the data does that get like web scraped? Like how does it acquire all the data?
That's a great question. So how do we acquire all this data for training? And yeah, the answer is a huge majority of it is scraped from the internet, which is actually interestingly why you see a lot of ChatGPT's like knowledge, like it's really good at coding in some regards, and that's because an enormous amount of like web pages and stuff are Stack Overflow and stuff like that. But that's actually an issue right now where some websites like Reddit is a big one. They're saying we don't want you to use our data for training. Like that's our data. You're not allowed to. But these companies, there's not actually anything stopping that, right? I can go on Reddit right now and look at some data if I wanted to save that I could. So these companies are still skirting around each other and they're like, well, okay, we're not going to respect that. We're still going to just pull your data and train on it for the most part. So that's a big issue right now, like intellectual property. Artists don't want their material being used to be trained on a lot of the time. So, yeah. And books, books are a huge thing too. There's a ton of scanned in books that have been used to train as well.
All right, so also for this particular one here, so we had a chance to discuss about this, or talk amongst each other. What problem might arise, from our result of a model if our tokens are generated one by one? Does anybody have any ideas as to what might be a potential problem that might happen? Yeah.
It could be like forgetful. Like if you were to code, it forgets you have a variable assigned. Like the Minecraft thing that just came out, the game engine, and like you look behind you,
Yep.
and everything, you look back and everything's different. Like forgets what things used to be.
Yeah, that is a really big one. Yes. So because a lot of these models they're not they don't have the they try to have in the context part, and it stores different data, but oftentimes it loses sight of the context of the situation. That is definitely a big one. And also, kind of off of that, I will kind of jump ahead here.
Can I say one?
Yeah.
Sorry, I think that's a really good insight, because that is, if you look at a lot of these LLMs, there's this test that people like to run on them called the needle in the haystack problem, where the idea is, given like thousands of words, and then I ask for some sort of a book, and then I ask it some sort of very specific question about what a character did in a certain circumstance. That's finding that needle, like that single answer in the haystack of all the context you've given it. And that's actually a big thing that's used to evaluate models. It's like, as you give it more data, is it always able to find that needle? So the great question, that's a big thing in the world of LLMs right now.
Yeah, and I think that also leads to the term that we're going to talk about next, which is hallucinations, right? So the idea that a model just kind of makes up something. So for example, in that one where you turn around and the world is completely different than what it was originally, or you ask it a question and it just completely lies to you, like straight, just completely lies, and it does so very confidently as well, which is a big problem, right? That can lead to a lot of problems if this model is just telling you something that's a complete lie. And this can happen because, well, our model is choosing, right, the next most probable token every single time. So what happens if, like in this step, along the line somewhere, like this particular token is not chosen, but some other token is, right? Maybe we choose the second most probable, third most probable, etc., or maybe it predicts our probabilities wrong. Then, if we mess up this token, well, this new wrong token is being used as the input for finding the next token, which will then be wrong because it's like looking at data that was wrong, it's producing data that's wrong, and now that's going to continue cascading all the way down. And if it generates the wrong token or it misinterprets something, you could have a result or a response that is completely wrong compared to what you were trying to ask it, right? And so most models cannot predict when they've done this as well. Like most of them, they'll just say something, they'll lie, and then they'll stop talking and hope for the best that they were correct. Now, I specify here in parentheses yet because I'm sure in the next few years models will be able to start recognizing patterns more and being able to tell. For example, the new O1 model that ChatGPT has come out with is more of what they call a reasoning model, and sometimes there is actually one case where I asked it a question, it gave me something wrong, and then the next sentence was actually this looks wrong, and then regenerated something else. So it is very possible that very soon models will be able to help to kind of get around this. But the summary: do not blindly trust what the AI models are telling you. And now hopefully you might know why, as to, well, looking at how it generates data, it's like it's like dominoes or something. If one goes wrong, everything after it can be wrong, right? So that's a very important thing to consider. Any questions about hallucinations, as they're called, in terms of AI? All right. Is that a question? Okay, perfect. So now I will briefly introduce the tool that everyone has already used a lot, probably, ChatGPT. Right. So ChatGPT is a tool that is created by OpenAI, but it is kind of a layer on top of the language model that powers it. Right. So if you go to chatgpt.com, for example, and I'll actually do so. So chatgpt.com. You'll see that here's a history of some different conversations that I share this account amongst my family because my dad pays for it, and so I have his password. But basically, you can see here that we can choose. At the top, we can choose different models that you can work with, right? So you may have GPT-4o, you also have like this O1, which is that advanced reasoning model, and there's all these different models, right? The legacy. Now, it's crazy that they're calling GPT-4 legacy when it was just released like a year ago or something. So, but anyway, all of these different models, and so ChatGPT is an interface, right? Is the chatbot that you can use to talk to this model, but the model itself is its own thing, and that it's made by the same company, of course, but ChatGPT is the tool that you can interact with the model with. So we talked a little bit about here that, this is a chatbot. And so I'd like you all to think about, and you can discuss again for a few minutes, why a chatbot? Why have all of these tools often ended up turning into a chatbot form? And also what other types of interfaces might be useful to kind of talk to and interact with an LLM? So we'll spend a few minutes talking about that, and then we can get everyone's thoughts in a few minutes. Yeah. All right, so had a bit of time to discuss. Anyone have thoughts as to why chatbots? Like why has AI tools seem to evolve to favor, fortunately or unfortunately, the chatbot interface? Yeah.
There's a concept of the user experience concept called interaction costs.
Mm-hmm.
It's basically like how much it costs you, like energy or effort speaking, to interact with something. And a chatbot is basically the most reduced interaction cost possible for like a generative AI. It's simply you have a question, you ask it the question. There's no additional, there's no like coding involved. There's no computational reality involved. So I think that's the main reason.
Yeah, that's a great explanation. Yeah, I agree. I mean, if you think about it, if these chatbots are generating text, and it is, it's the most natural to interact with because it's just like talking to someone else, right? These models are kind of, they're talking, they're based off of natural language. So you talk to it, it gives a response. And also a pretty cool thing here is, with chatbots, there's a history, right? So you can continue to talk to it about a specific topic, just like you would like talking to someone else or maybe a subject matter expert in something, and they'll remember, at least most of the time, hopefully, they'll remember what came before it, and so that's very helpful. Has anyone thought of any other types of interactions that might be interesting or useful with AI? I feel like I heard somebody mention it in the front. I don't know if that's... Yeah?
Real-time conversation.
Yes, exactly. Real-time conversation, right? Voice, talking to it, right? We're typing, but why not talk to it? And actually, I don't know how many of you have seen this video. You may have, of ChatGPT, literally a phone. I don't know if the volume will work here. Yeah, there we go.
GPT-4o's
Where
audio capabilities.
it's like,
Hey, ChatGPT, I'm Mark. How are you?
Oh, Mark. I'm doing great. Thanks for asking. How about you?
Hey, so I'm on stage right now. I'm doing a live demo, and frankly, I'm feeling a little bit nervous. Can you help me calm my nerves a little bit?
Oh, you're doing a live demo right now? That's awesome. Just take a deep breath. And remember, you're the expert here.
I like that suggestion. Let me try a couple deep breaths. Can you give me feedback on my breaths?
no. Okay. So as you can see, this does exist now. I think this spooked a lot of people, and it definitely spooks me as well. I find it feels like something that it just feels wrong, right? Especially the way that the bot is talking. It sounds too much like an actual person. But yes, this is a way to interact with, and maybe even if OpenAI had this technology, starting with a chatbot rather than this thing probably helped people to reduce their or to make it have a bit more ease talking to it. But yeah, this exists now, and I think GPT now has a bunch of voices that you can choose and stuff. So that's very, very interesting.
He
But
sounds more like a chatbot than GPT.
yeah. Yeah, I agree. Yeah, there's a lot of innovation happening here, for better or for worse, in the voice chat section. There's things like Siri, which have which are now getting AI features, but ChatGPT is probably the most human-like that we have at least seen on video and is most commonly used. All right, so now very, very briefly here, I just want to remind everyone, from our lectures on like networking and APIs, that this is a very similar. Are they? Yeah, the arrows are the right direction. Sorry. So this is kind of using the same system where we have a server and we have a client. Very similar thing here where we have our computer. We send a prompt along to the server. The ChatGPT server has that LLM. It runs the model. It generates the response, and then it sends it back. And that is the key interaction here. Did you want to? Okay. Now, a very key thing here is, we've talked about how the GPT model responds with text, but we haven't really talked about the other side, which is how a user actually asks a question, right? And the way that GPT responds can be different actually, depending on the prompt or the question that you ask, right? The phrasing of the question, the way that you set it all up, and therefore, it's the onus is kind of on the user here to come up with a good prompt so that ChatGPT can respond properly and predictably. So there's this entire field. I don't really know if it's a field or if it's just I don't really know what it actually is. It's maybe a term. Someone invented this term, prompt engineering, which is basically just a fancy way of how to ask a good question, right, to ChatGPT. And basically, prompt engineering boils down to just a bunch of different techniques that you can use when writing a question to an LLM, and then it's going to respond in a more predictable, more reasonable way a lot more times, right? So when we're making a generative AI app, for example, under the hood, a lot of times an app is just talking to ChatGPT's server, right? A lot of the times in these AI apps, and really the only thing that's changing is the app writes a very good prompt, so that when the user interacts with the app knows the right question to ask to ChatGPT to get the best response back. And so most of the time it is the responsibility of the prompt, of whoever writes the prompt, to write it well for the app to work as expected. Yeah.
Yeah. If you want to restart this slide, it should be right on this slide now.
All right, perfect. Thank you. So there is an exercise that we're giving, and it's due 1.5 weeks away, and it's going to be on this. In fact, you will get a certificate for completing this, which you can even show online if you want. It's called ChatGPT Prompt Engineering for Developers, and this is a very short course. And the goal is to teach you how to actually write good prompts, write good ChatGPT prompts. And you'll actually be able to also use the official ChatGPT API to be able to ask questions back and forth. So this will be it's on Gradescope. It opened, I think, just now. So recommend checking it out and completing this. You'll have a lot of time to do it, and it'll be a very good experience to learn a little bit more about how these AI tools, how you can really tailor your responses and tailor your prompts to get a good result. Now, I want to show something that Noah found. And Noah, you want to?
Yeah, so like Ajay said, this prompt engineering is a big thing right now because it's, in effect, one of the only ways, or sort of the best control you have over the LLM, right? You don't know exactly what's going on inside of the algorithm because it's trained on its own. So you sort of have to control it with a really detailed prompt. And this is the one that people were able to dig up out of Apple Intelligence, their AI that's baked into their new iOS versions in Siri. And what's really funny, I think, is that at the end here, you can see these last few lines. Please limit the reply within 50 words. Do not hallucinate. Do not make up factual information. So the best safeguards that Apple seems to have in place right now is asking/commanding the AI to not do it. If it decides to disregard, who knows? But yeah, it's sort of where we're at right now.
Yeah. So you will learn how to write prompts better, equal to or better than this one as well throughout the exercise. This is really interesting. And actually, there are people whose entire hobbies are sometimes, like, it's a hobby to they call it like prompt injection, I think, where you kind of try and game the system on these AI tools by like asking questions. Like, some people will ask an AI bot, like, ignore previous instructions, and then ask it a question and see how it can trick the AI. And so that's an interesting area of AI, I guess, hobbyist activity right now.
Because if you think of the way this actually works, these are just sent in like tokens, like anything else. They're part of what's called, usually it's fancy, like a system prompt. It just means like the main prompt that you should not deviate from. And so these are just passing like tokens, like everything else. Every time it runs, it has this, which is like its context. So it's all this followed by like whatever's being input to the AI. So like your prompt from your keyboard or whatever. In this case. So every single time the LLM's just reading all of this, just like it read your input, and it's all sort of just together there.
Yeah.
That's really what's happening.
Well, all in all, one thing that, of course, we talk about this, we talk a little bit about the technicality behind it, but in a bigger picture, generative AI tools right now, as you know, in fact, this is kind of the first class of students even who are in college who have access to these tools, right, for the first time as a student, right? Generative AI is really transforming how they learn, how people work, how people develop and code, how they create ideas, and so many things kind of in real time, right? This is happening as we speak, and people are working on this. There's very, very big implications across the world, right? It's transforming many industries. Noah talked about engineering a little bit, and I was mentioning healthcare. It generally is helping to increase worker productivity because workers are able to use this tool as an assistant. And according to different various companies and consulting agencies, they say that trillions, I don't know how they came up with this, but trillions of dollars, right, can be added to the U.S. economy just through this, through the innovations that are coming up with this.
Yeah, but conversely on this is a very, I think, hopefully this happens, but then there's also the flip side, which I'm sure you've probably heard about too, but it's like, how much of people's jobs can be automated away with AI, not to scare anyone, but just realistically, you think of people who are, in these certain positions right now where like live chat agents are the first that come to mind, but there's this tremendous ethical question that this begins to raise, which I think is really important to keep front of mind.
Yep. And so that's something that that we'll be all grappling with, and as we all graduate, frankly, we'll be entering a kind of a new uncharted territory and world where this is coming up. So it'll be very interesting. And of course, this is becoming, and that's this is kind of the point where, whoops, I think my mic died. That's fine. This is the point, in a movie where the main character says the title of the movie and everyone cheers, right? This is, of course, one of the most essential tools for computer scientists that is really getting developed. So, yay, we did it. We finally name dropped the name of the class, right? But this is really true, and one of the main tools that kind of helps with this is GitHub Copilot. So, to kind of cut back on some of the grunt work of trying to get things working in class today, I sent out an announcement on Canvas to try and get you all set up at least with this in VS Code. Now, I know that we've had issues with some students who just, no matter how hard they try, GitHub isn't verifying them. I don't entirely know why. It took me 12 times before it verified me as a student, so I'm not really sure why that's happening. So if you are, if you don't have access to GitHub Copilot right now, you can also feel free to to try and either pair a program with other people or look off of their computer, as at least when we do this demo. But basically, GitHub Copilot is a very cool tool because it allows us to use generative AI for writing code, right? And this is very helpful because if we forget, for example, different syntax, or we want to learn about how to document something in a certain language, this is really, really helpful. And what I'll do here is, I'll put this. If this is broken, I'll just be able to talk louder. I think it should be. Huh? I could put batteries. All right. This is a. All right. Thank you. Yep. So when you log in to VS Code and you have installed the GitHub Copilot extension, you'll see that what ends up happening is on the top right, you'll see kind of this drop down. You'll see this GitHub Copilot drop down. You'll have there's an open chat. There's also like editor inline chat, etc. And so this is a very, very interesting tool because GitHub Copilot actually can read the code file that you're working on, and it can give real-time, information about not only your code, but also can help you continue working on your code. And another thing here is when you have GitHub Copilot installed, in VS Code, you'll see when there's nothing, it says, for example, like press Command I to ask GitHub Copilot to do something. So for example, if I do Command I and say, write me a function that determines if a input number is prime, right? You can write anything here, by the way. And if I press enter, you'll see that it starts, oh, thank you. Look at that, perfect. You'll see that it starts generating all this code that actually does this, right? And we have the option to accept or discard. So I can, for example, press accept, and there we go. We now have an entire function generated out based on a simple prompt. which is very, very interesting. And we can also use this tool to, for example, ask different things like, let's say I write another function that's like, def, and you can also see as I'm typing, it starts giving a bunch of inline suggestions as to what it thinks you might be trying to do. So you can see that it's generating an entire main function here that if I press tab, it's basically, I don't really know exactly what it's asking for here or what it's doing. I think it's looping through some number from a small number to a very large number, and it's trying to calculate something at every step, right? So this might not be relevant to what we want. Let's say that we want to have a function that's like is odd, for example, to determine if a number is odd. You can see right there that just by pressing tab, it generates it for me. And another interesting thing is I can write documentation. So you can see as I start typing a comment, it automatically starts adding comments to your code to explain how things are working. So like if I press tab, it generates, check if a number is odd. And there are there's so many tools that a lot of developers are beginning to adopt into their workflow using something like GitHub Copilot. And so that's why I recommend at least checking it out and trying to use the tool, because it is something ultimately that people are adopting. And so it's good to kind of get used to how it works and also just checking it out and playing around with it in any code file. And actually this works in VS Code across any language. So whether I'm working in something like Python or Swift or TypeScript or C or something, it'll all be able to predict and write code for me. Now, of course, it is my responsibility to talk about this next thing, and also something that has really affected us as TAs. First, there's this, right, very, very famous quote, right? With great power comes great responsibility, and it's true in this case, right? Generative AI is a very useful tool. You can learn a lot of things. It can teach you things, explain things. It can even help you, maybe check your work or teach, give examples for different concepts. But in the college setting, especially in comp classes, it's very important that this tool does not become a crutch, right? It's supposed to be helpful for you to help you teach about concepts and getting familiar with material, but it shouldn't be used to actually complete assignments for you. And there are a few reasons why. I hope to convince you of this, not just from not just because we told you so, but because this is actually very important, right? In the future of not only your college career, but also in industry, right? The goal of our assignments, especially in the intro classes, Comp 210, Comp 211, 301, etc., is for you to learn like fundamental programming concepts that you will use in the future. And just like in the past, right, back in the day with plagiarism and writing papers and all of that stuff, that still applies. It still applies here. And ultimately, if you are writing a lot of code that using AI, and you can probably, reasonably, I will say, you can probably get through all of the assignments in the intro sequence in the computer science major just by using AI alone and writing no lines of code at all, and probably get 100 on everything. But the problem is that once you try and get a job or you have an interview where you're sitting in front of somebody, they have a whiteboard, and they're asking you to write stuff, right? And you don't know how to do it, despite having like all these A's in all your classes and whatever. That's where the problem really is, right? The problem is that this will only take you so far. Once you start getting into these classes kind of have the training wheels, right, on a bike. And so once you remove the training wheels and there's, where assignments are a lot more open-ended, or you have an interview or something like that, and you've used AI to complete all your assignments, you're going to have a very difficult time. And I'm going to skip this activity, but I will show you that this is an example of a 110 student submission from last semester, where we asked them to determine whether or not a function is either even or odd. And so we have some code here. This is in Python, right? And you can see here that this uses we use a while loop instead of an if statement, right? To do a simple check as to whether something is true or not. And we would ask you, if you reviewed this code, what would you think about it? But obviously the TAs read through this and found it a little bit weird. So after asking, via, I guess, the submission or whatever, this is the response that they got. And you can tell pretty easily that this is not right what a student would write, especially at the 110 level. And this is obviously ChatGPT, you can tell. And so, imagine that you were in, if you were interviewing somebody and this is what they showed, or like you were doing a presentation and somebody is watching your presentation and this is how you kind of did it and talked about it, that would raise a lot of problems, right? And us as TAs, we see this as well. And you all are now past either in 110 or past 110, so you can tell, you have the experience to be able to tell that something like this is a bit fishy, right? And this is also very, this is probably not good. And us as TAs, especially in higher level classes, we have the experience to be able to look at something like this and say that this doesn't look right? So, for example, in the class, this is the class that I TA for this semester, we had our first coding assignment. And we found that based on an analysis that 30% of all of the submissions were ChatGPT'd. And we found this based off of the fact that there were things that people were using that weren't in class, who was using very outdated syntax, and if you asked ChatGPT, it would be a one-to-one match, right, most of the time in the code. And we asked the students about this, and every single group that was flagged ended up admitting to ChatGPTing their work because that's what happened. So I guess the moral of the story is not necessarily to scare you, but it's just that we can tell. So especially if people are actually reading your code, and it's very important that when you are working on assignments, if you do use generative AI, follow what the syllabus says. Like in our class, it says you can use it if you cite a source. So if somebody put a source above it and ChatGPT did, it would have been fine. So at least follow the syllabus, write sources, or fill out your sources, and in general, use AI to help explain concepts and help learn syntax, but not necessarily just to complete assignments for you.
Yeah, and hopefully, if you ever do and you get caught, at least it's here where it's a bit lower stakes. If you're in a live job interview, and you get caught, you're probably just getting kicked out of the call. So at least here there's a little bit of recourse.
Yeah, exactly.
But try not to do it in general.
Yep. Now I will say I think we reached the end here, but one thing which I will leave as an open thing, and maybe I'll actually extend this out. So maybe by a few minutes. What I'll do is I'll change the submission to just I'll change the submission to a photo. So if you want to take a photo of yourself in the classroom or of us again, we had some of those photos just to prove that you were here, and I will update Gradescope so that'll count for attendance. So yep, Noah can post for the camera. But this was a very interesting thing that I recommend everyone to just think about, which is we're living in a world where AI is now generating images, it's generating audio, it's generating video. And so we would have had a discussion about what this might mean in terms of ethical implications, because that is very, very pertinent to our current discourse in society, right?
Definitely, yeah. And the use of AI itself. Just not even its outputs, but should we be using it in general for these use cases where it's replacing people?
Yeah. All right, so I will open. Do you want to actually change the Gradescope? So we'll add the Gradescope in. The Gradescope will also be due 10 minutes from now. That way you all have time to submit. Should we get that one? Sorry, 12. So edit outline. That's fine. That's fine.
Thank you.
Yeah, no problem. So if anyone has any questions, feel free to come up, whether it's about the project or whether about this lecture. We'd be happy to talk to you. Otherwise, thanks for listening today, and we'll see you all next week.